Simon, what's up? What's up? What's up? What's up? Hello, hello, hello. So, I have nothing to do yet again, so I decided to stream. And I decided to stream some sort of like a neutral topic that is not related to any of my projects. Just, you know, something. Just something. And implementing a hash table in Rust sounds like a pretty interesting exercise. And hopefully pretty educational one as well. Jiang, what's up? Lily Monade, I think this is how it's supposed to pronounce. Hello. So yes, kawaii fucking desu. Let me create maybe a readme. Do we even have a readme? Let me see. readme.md hash table implementation implementatino in Rust. So should we actually give the link to the Rust official website? Purely for educational and recreational purposes. Right. Purely for educational and recreational purposes. For real world use cases, for let's call it real world production, please use std collections hash map, right? Hash map. So let me go there. An ordered map, yeah. An ordered map. And let's just put this link in there. So just in case. Please use, right? Please use. For real world production, please use this thing instead of whatever you see in here. Hello OctWTF pre-0. Hello everyone who just joined. So what kind of reference are we gonna have? References for now, as a reference for hash table implementation, I'm gonna be using the Wikipedia article, because Wikipedia is the most reliable source of any information, as you know. Hello everyone who just joined. Hello. Yes, license. I don't even want to put it under MIT because I think it's too much. So can I just make it a public domain? License for software. So whenever the PhD says all my citations will be Wikipedia. Public domain equivalent licenses. Okay. Public domain software. The fuck is this? MongoDB? So am I that fucked up? I think oh, it's a WTF. Maybe that was the purpose. I think that was the purpose. If it's WTF, that's essentially what it is. Okay. It's kind of funny that you're looking for public domain equivalents and this is the first thing that appears on Wikipedia. That's the pretty hardcore shit post, not gonna lie. Public domain software. CC0 copyright Weaver Lance's logo. Too much work. We released Nintendo MIT. Okay. Anything else? Anything else? Quick start. I suppose quick start is gonna be just doing something like console holo cargo run. Oh, we got a sub. Excuse me. Okay, TWTF, thank you so much for Twitch Prime subscription, your first subscription, by the way. I don't know why you subscribed. I haven't written a single line of code yet, but thank you very much. Thank you, thank you, thank you. So we're gonna wait a little bit until the rest of the people actually arrived, and we're gonna start implementing. Who knows what the hash table? Who knows what the hash table? Wikipedia knows. It's a data structure that implements an associative array abstract data type, a structure that can map keys to values. Yes. Hash browns. I wouldn't mind some hash browns right now, to be fair. Yep. Some pH potato. Yes. Some sweet carbs. Sorry, doesn't. All right. So essentially, it's an associative array that has a key, and it stores a value under that key. And the idea is that looking up in that table should take O of 1, basically constant time, amortized. Amortized means that on average, it's going to be constant, but sometimes it's going to take maybe O of n or worse time, but it's not going to happen too often. In fact, it's these kind of like slow operations are going to happen so rarely that overall it is, you know, it is negligible, and it is acceptable to consider the time as O of 1. Right, so that's basically what it means. If I remember correctly, I might be wrong in some details of the definition, but I'm not a computer scientist, so I don't know anything about data structures and algorithms. So, and yeah, that's what we're going to implement today. So I guess there are two main things that we need to consider. The way we address the buckets, right? There's open addressing and closed addressing. Is that what it is? I don't know. And another one is, it's a separate chaining. Yeah. So there's a separate chaining and the open addressing. So we need to decide a collision resolution technique that we're going to use. And we also need to decide what kind of hash function we are going to use. So the main idea is what? The main idea is what? Let me take this thing. So essentially, you could, if you need associative array, you could always just store an array of pairs, right? You could just store an array of pairs. So, and each element could be something like that. It could store a key value, then a key value, a key value, and so on and so forth. Then if you want to look up a value by a particular key, you would go from left to right and check each and individual element in that array, and that would take you O of n, right? But there is an interesting idea. What if there is a unique function h that takes your key, right? That takes your key and gives you some sort of an index in that specific array where this thing is located. That way, if the computation of that function is O of 1, you could just take your key, right, take your key, some key I, take a hash of it, and then use it as an index in your array and quickly find what you want. Of course, such function is really difficult to craft, especially if your key is something complex, like a string or even a structure. Right, but you can come up with a hash function that sometimes collides into the same sort of bucket, into the same element of the array, but quite often it actually goes into different ones. So in that particular case, instead of array here, you can have an array of linked lists, right? Array of linked lists. So, and those buckets are basically represented linked lists where you store your pairs key value, like so. And this is going to be key 0 v1 v0, key 1 v1, and so on and so forth. v1 Zulu. So now, if you take your key, calculate a hash of it, and take an index, you would have to find it in a smaller amount of elements, right? So basically, you will only need to find it in a single bucket, which will speed up the process of looking up dramatically. Right, but this is, I think it's a separate chaining way of addressing things, right? It's a separate chaining way of addressing things. There is another one which is called open addressing. Essentially, if you have a collision, you store the chains not in a separate linked list, but in a neighbor elements, right? So if you have a collision in here, you would actually move to the next element. If the next element is already taken, you're going to move to the next element, and so on and so forth, right? So there's two different ways to resolve the collision. But the idea is the same. You have a structure that represents the key. You have a function that can turn that structure into an index, and you use that index in an array. And if you have collisions, you resolve this collision either by using linked list for a specific bucket or just placing them nearby. So that's the whole hash table. Hash table is pretty much like a, you know, enhanced version of the array, right? Does it make sense? Does it make sense? Hopefully that makes sense. Okay, so good explanation. Really? I think I kind of jumbled it a little bit. So I don't know. I'm usually not really good on with explaining things on the spot, right? I'm usually good when I prepare for the explanation, but I improvised this this entire explanation, so I'm not sure if it was good or not, but I tried. So we need to decide what we're going to use. What kind of hash functions are we going to use, and what kind of addressing are we going to use? So let me see. Let's define the hash table as a structure. It's going to be a hash. Let's call it hash table, right? Let's call it hash table.
Zazin checkout DJB2 hash function P.
Yes, spoilers by the way, but at least you paid for it. Thank you. Thank you so much for 100 bits. Thank you, thank you, thank you. Yeah, so for as a hash function, we're going to probably be using DGB2, right? It's like a usual one that everyone is using. So the algorithm was first reported by Dan Bernstein many years ago, and everyone is using it for some reason. I don't know why, but yeah. So apparently maybe it gives a pretty good, like a few collisions, fewer collisions than if you would just take all of the characters and just sum them up together. So maybe that's why everyone is using it, but there's no much explanation.
Annotir spoiler for Yatiki let Kenny.
Yikes. I think, is there like a map I remember there was like a map. Yeah. I think. I wish I could find the original. I found something on fucking Reddit, which is a screenshot from Twitter. But I guess the idea is Kenny dying as a joke was like for a first few like episodes, and now it's a fucking dead meme. Yikes. So, but thank you so much for 100 bits. All right. So, what we're gonna use? We can try to use. I kind of want to use open addressing, to be fair, the one where you store things like nearby, because in case of a chaining, you basically may run out of buckets really quick, and at some point you will have to resize it anyway, and you'll have to decide when to resize. When in case of open addressing, you know when to resize when you ran out of elements, right? So if you ran out of elements, you just, you know, resize the entire thing. So I kind of want to go with that. Yepers open addressing. Yeah, I kind of like it better. So we're gonna store them in a vector, because vector will make it easier for us to resize everything. And also we need to specify what's going to be the key, what's the type of the key, and what's the type of the value. Right, and what we're gonna store in these things, we need to store both key and value, because when the collision happens, we'll have to compare the key with the key that is actually expected there, right? So that means we're gonna store pairs of key and value. And how we're gonna call this particular thing? We're gonna call it key vs, meaning that key value and s means that there's many of them, right? So that's basically what it is. So yeah, the next thing we need to do, we need to implement constructors for this thing. So this one has to be like this, and it's gonna be hash table, and you have to repeat this thing twice for some reason. And interestingly enough, I want to have two constructors, right? Something that can create an empty key map, which returns self, right? So this one is going to be to do. And so this one is default, but another one that I want to create is a hash map with a particular capacity. Right, so I don't know how to call this method. Let's call it with capacity, right? So, and you're gonna provide the initial capacity like this, right? And this is gonna be a self. The reason why I want to do it like that is because when we're gonna implement a resizing, what I'm gonna do, I'm gonna just create a new hash table with a bigger capacity and just copy elements there, just add elements there. How long did it take to you to write code this fast and never making mistakes? What are you talking about? Your question has a wrong premise, so ask a correct question, please. All right. So these are only constructors. So now we need to implement operations, right? We need to implement certain operations. First, I need to be able to add, maybe insert a value by a key. So it's going to be key. So I suppose, you know what? I kind of want to call this generics by their full names. Yeah, I think it's gonna make the code look very fucking cool, mate. Yeah. So, readability. So this variant of insertion actually takes the ownership over key and value. So you have to take that into account. So essentially, we're moving them inside of the hash table. So the thing about passing thing by a value in Rust is that when you pass it by a value, in the place where you pass it to is now going to be responsible for freeing any resources of these values, right? So after you moved it inside of the hash table, you won't be able to use it outside or deallocate it outside hash table. Hash table has full ownership of that thing. And I think that's okay for inserting, right? So the next thing we want to do, we want to be able to get a value, right? To get a value by its key. So in that case, we don't really need to take the ownership of the key, so we're going to pass the key by a reference, and what we're going to get in here, I suppose we're going to get a reference to a value, right? We're taking the reference to a value. This thing is not implemented, of course, yet. This thing is not implemented. There we go. So, but sometimes you want to actually modify the value. So as far as I know, in Rust, it is done via a second method, which is usually prefixed with mute. And instead of returning the immutable version of the reference, it will return a mutable one. So, yeah, as you can see, Rust didn't solve that problem. So, it's just so fucking funny. Yeah, you need both versions, like mutable and immutable one. So they had an opportunity to improve the usability of C++, but they decided not to, because usability of the language is not a priority of Rust. Yes, it is not a priority of that language. Priority of that language is safety. So it's like a very, very secure butt plug. Why did they compare it to butt plug? I don't understand why, but yeah. So what I'm trying to say, well, okay, whatever. Let's not go there. About things, how to solve this for Flags. Yeah, to be fair, I don't really know how to solve it in general, so I didn't think about it too much. Deep Singularity, what's up, what's up, what's up? Okay, WTF, I hope you already regret subscribing to this channel, so welcome. So, we need to have insert, get, and I guess another thing that we need to be able to do is to remove the element. To be fair, it's kind of difficult to remove element in open addressing, right? It's kind of difficult to remove them. So, because usually, right, what you end up with is you end up with the following chains, right? The following chains. So, and essentially, if you collide into one of these elements of the chain, right, you basically continue moving like to the right of the chain until you find something. But if one of the elements get deleted, the whole chain sort of breaks. So instead of breaking the chain, I suppose what people usually do, they just mark certain elements as deleted, right? And so that way you should be able to skip over some of the deleted elements and something like that. We're gonna synchronization issues for status, right? Synchronization? What? Synchronization? What? What synchronization? I don't understand. Okay. So, do we want to delete elements? That's the question. I guess for now we probably don't want to care about it too much. And just not implement it at all. So implement with capacity. I'm just thinking how we're gonna do all this. Well, the easiest way to go about that would be to actually have like something like new. Well, let's create something like new. Yeah. Let's create something like new, and it's gonna just return self. I don't know why I'm making it a little bit like more difficult for myself. So now let me go to the documentation and see how I can create a vector with a certain amount of elements in it. With a certain amount of elements in it. So there's something like a reserve probably, right? So you can reserves capacity for at least additional more elements to be inserted in the given vector. The collection may reserve more space to avoid frequent reallocations. After calling reserve capacity will be greater or equal to, okay. I guess I remember the vec macro had pretty useful parameters, I think. Let me see, that allow you to specify the size, right? Yeah, there we go. So I can just allocate a certain capacity, like a starter capacity. So this one is going to be self, and we're going to do kvs, and it's going to be simply vec1, and we're gonna, so key has to have a default implementation, I think. Key and, yeah, both key and value have to have default implementation. So yeah, let's for both of them say that they have to have something like a default, right? Something like a default. And so let me see, so this is going to be key, maybe, yeah, key default, right? Key default value default, right? So this is going to be the value that you want to put here, and then we're going to have something like initial capacity, right? We're going to have initial capacity. And we're going to put something like const initial capacity is going to be usize equal to how much do we want? 69. Is 69 a pretty good initial capacity? So yeah, maybe 69 is like not really good, not really good number, because it's not like a power of 2, so you cannot like divide it by 2 or scale by 2. Let's actually put something like 64, because it's closer to 69, right? So since it's closer to 69, I think it's a little bit better value. All right, so I think this is going to be our implementation of new. Just our implementation of new, and let me try to recompile this entire thing. Yeah, I never even tried to compile this entire thing. Let's see if I can even compile it. Maybe it's not even compilable. Maybe I violated all the laws of borrow checking, and now my code is absolutely unsaved and absolutely garbage and deserve nothing but the wall of shame on CVE database. Right, let's find out if it's not gonna go to CVE database. So CVS. Okay, so cargo build, CVS database of vulnerabilities. Okay, self. Oh, okay, I put a here. All right, so it's not the default because I forgot to call it as a function. Okay. Forgot to call it as a function. So let's continue. Now, so maybe I'm gonna actually put something like a debug in there. So it's gonna be derive debug, right? So it's gonna be derive debug, and yesu. Within key value the clone. So they need to be able to clone as well. So we'll have to force the elements to be clonable. That is very interesting. That is very interesting. So it has to be clonable, but this actually takes too much effort to actually define it as clonable and stuff like that. So I don't fucking know. But maybe that's all right. Yeah, I wonder if there's like a way to sort of like squash this entire thing, something like, you know, t, and then, you know, where t is equal to something like that. You know, there's like a syntax. I remember there was like a syntax in Rust that allowed you to do that, but I don't remember specific of that thing. Could not find trait t in the scope. Yeah. Oh yeah. So you can only do it like that, where k is equal to that, and value is equal to default plus clone. But yeah. So to be fair, I don't know how to do that, so I'm gonna put it in here. We're gonna put it in here. I guess for now we're gonna keep it like that. In Rust we thrust. Oh shit. My mouse is shit actually. Okay. Yes. Go away fucking this. So we need to do an insert, right? Oh, we also need to be able to like provide the hash function. You know, in Rust, it's usually done with, I think, hash trait. Yeah, there is a hash trait. So we can implement our own hash trait, or we can just use the hash trait from the standard library of Rust, right? So it also accepts the state, which is kind of weird, but okay. Which is kind of weird. Tries to types implement hash are able to be hashed, but I'm not sure about the state. So what is the state? So there's a default. Oh, it's one of those things. Yeah, it's one of those things that require that. Monkey Life, hello. Welcome to the stream. How are you doing? Hello. Let me check. Okay. 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 So I'm just thinking, do I want to like have a hash type on my own? I think I do want to have my own hash trait, because this hash trait is too complicated. It has the state, and I don't understand why the hash function is not just a function that accepts the key and returns you some sort of an integer, or maybe usize, right? I just don't understand why it is not like that. So we're gonna have our own trait that implements hashable. Right, so let's do it like this. So it's going to be trait, and it's going to be hash. But I'm not quite sure if I want to call it hash because it's already taken. So let's call it hashable. Right, the trait is going to be hashable. And we're going to implement a method called hash, which accepts a value, right? It accepts a self and should return use size. Right, and one of the main things that we have to ensure here is that key is hashable. Not hash table, but hashable. So key has to have a default value, it has to be clonable, and it also has to be hashable. The value only has to be defaultable and clonable. And all of that is needed precisely so you can predefine a certain amount of like buckets and whatnot, right? Certain amount of buckets. But I think you won't need, you actually may not need this kind of shit if we're gonna use the chaining resolution, separate chaining. Yeah, so if you use a separate chaining, right, so we're gonna have buckets and you have a vector of pairs. So in here, you can just do buckets and you can just pre-allocate a bunch of like empty buckets in here, you know what I mean? And because of that, keys and, you know, keys and values don't have to be defaultable and clonable. Prime number, yeah, I guess that makes sense. What's the closest prime number to 60? 64? 61, okay, let's put 61. I think it does make sense. Okay, so yeah, and I think it will compile. So with buckets with separate chaining, right? With separate chaining, I think it's gonna be all right. Within the trait clone is not implemented. Oh, it wants to be cloned. It needs to be clonable, even though it needs to clone empty vectors. Okay, so let's go back to open addressing, I suppose. So we're gonna key yes. We're gonna only have this thing, and in here we're gonna have a bunch of defaults, which is key default, value default, right? Value default. It's gonna be key vs. Key vs, and so again I'll need to be doing something like clone plus default plus that, and this one is going to be clone plus default. Yeah, clone plus default. Okay. So let's create something in here. So hash, maybe something like mute, names, maybe dictionary, maybe not dictionary, but so what we're gonna store in there, something like phone book, maybe. So it's gonna be hash map, maybe hash, yeah, hash table, and we're mapping a name, a particular string to a particular value that could be, I don't know. Let's also make it like this. Yeah, there we go. So, and because of that, I want to do something like new, and there we go. We created a new hash table, and I want to be able to print the hash table, but that means I will have to implement a printable of this thing. Let's see if it's compilable. Let's see if it's compilable. Doesn't have a new. Excuse me. Function or new not found for this. Well, that is not true, isn't it? So hash table new. Did I miss something? I feel like I missed something, because here's a new, and yeah. Oh yeah, oh my god. So just string has to be hashable, so we need to implement hashable, right? Implement hashable for a string, right? And in here we're gonna have a hash value string, and it's gonna be useSize, right? So the hash function that we're gonna implement the DGB2, right? So I'm gonna put this thing in here. There we go. So let's implement this thing. Maybe I'm gonna do even the following thing. So we're gonna take println hello world, right? Hello world, and we're gonna do hash, right? And let's see what's gonna happen. So this is the algorithm that we're using in here. So the final result is going to be something like, yeah, let's do mute hash 5381, right? 5381. So we also have C as a character, but I don't think we'll need to do that. So we'll need to iterate through the characters. So, but for the characters, we need to know their codes, right? So that's kind of the point. So maybe the thing I'll have to do. By the way, I'm pretty sure we need to pass self by a reference, so we don't accidentally move it in. That's for sure. And yeah, since it's a self, it has to be self, of course it's a, yeah, in the Rust it's actually self. All right, so then it's going to be self bytes. We're going to actually take bytes, and yeah, for all of that is going to be hash equal hash 5. Oh, by the way, so let me quickly mod you. Jia, you are mod now, and the command is subscribers. So this command enables subscriber mode, and the command that disables subscriber mode is subscribers off. Right, it's these two commands, subscribers and subscribers off. So if something like that happens, feel free to enable disable subscribers mode. So yeah. All right. Plus hash and plus C. So that's the hash essentially. I hope it doesn't happen. Even if it happens again, it's just like super easy to get rid of. It's just subscribers mode. So subscribers mode, like wait for 10 minutes until they get bored of it and just disable it. It's just like it's a pretty common situation in Twitch. Nothing special. Nothing particularly special. All right, so hash is already taken as a name, so maybe it would make sense to actually call it something like result. Yeah, I think I'm gonna call the result. There we go. So here's the hashable, and let's see if it compiles on it. Yes. Println has to be a macro. Println has to be a macro, and excuse me, expected useSize. Oh, okay. So it couldn't actually infer that result has to be useSize. I have to explicitly tell it that it's a useSize. All right, plus C. So I'm pretty sure I can do something like into. And is it working? Cannot satisfy useSize as add output. But I'm pretty sure you can convert it to useSize. I mean, as useSize. It's a U8. Shouldn't be that hard to do. Method not found. Oh, this thing has to be something like toString then. And yeah, so we managed to do that. So let's do run, and it didn't really run for some reason, didn't it? Exited abnormally. Attempt to add with overflow. That is very interesting. So, but what if we want overflow? Maybe that's exactly what we want. So let me, I think I remember there was a way in Rust to explicitly say that we want to add with overflow. So add with overflow. There we go. So add with overflow. So T is a copy of performance. Is it safe? It's a Rust intrinsic. Overflow and add. Oh, okay. All right. Calculate. So returns a tuple of addition along with boolean indicating whether the arithmetic's overflow would occur. If an overflow would have occurred, then the route value is returned. So you can actually, yeah. So I think safety has gone way too far. So if you wanna just rely on overflowing the value, right? You have to use this clanky API as a ways of confirmation that yes, I know what I'm doing. You may prefer using, oh, there's a version of without boolean. Okay. So let's take a look at wrapping add then. Wrapping add. Oh yeah, okay. So we do have that. So, and specifically we need use size information, but I mean, it's still less convenient than just plus. Okay. All right, so that's a little bit better, but not as that much. So wrapping add. Right, wrapping add. Yes, and yep, that's what we got. As to isn't that visible? Yeah, I would prefer like a separate operator. I think method, such a clunky huge method, is too much, in my opinion, especially for a language that is supposed to be low-level language. And in a low-level code, you have to do a lot of things that may rely on overflow, and you want to make them as comfortable as possible, right? So Rust might be a low-level language, but it's definitely not a comfortable one. So it's just like, I don't know. Panic on size -1, yeah. So I wonder why can't you just convert it to into? Maybe I don't understand what is into, so maybe it's not. Oh no, would you look at that? It's you can actually do into. In here, it's kind of strange that bit shift is not something that you have to confirm you know what you're doing, right? Because bit shift can screw up like your number pretty badly, like on the level of bits. So, or is bit shift has a semantic of just multiplying by 2 and dividing by 2? In that case, like it doesn't matter what are the actual bits. It might be, maybe it just has a semantic, so it's relatively safe because it's just multiplication and division by 2. I wonder if bit shift can result in overflow. I'm actually kind of curious.
Please mark your create sans office so people know you are using dangerous math.
But it's not dangerous. The function that I'm using is not marked as unsafe. So that means I'm using safe math. If it was marked as unsafe, I would definitely mark it as unsafe, but it's not. That means it's safe. That's the reason why it has such a long name, to be more safe. Because everyone knows that the longer the function has the name, the safer it is. Thank you so much for 100 bits. Thank you. So what I want to do, So what I want to do, I want to just put, or maybe it's like 200, right? And I'm going to do let mute x, use size 69, right? And it's going to do xx1. Println, and it's going to do something like this. X. This is not panic worthy. So this is not panic worthy, but overflow is panic worthy. I guess if you're using bits, you kind of know what you're doing, right? Because you're right. So people who might be beaten in the ass by overflow probably don't know how to use bits. Is that the logic here? Or maybe it's something else? So it's kind of feels a little bit arbitrary, but okay, sure. It's totally fine. Okay, so yeah, we now have a way to hash these things, and everything seems to be working, right? So here is the value, and I suppose I can confirm that it's the same albeit every time, and then we can always like mod it to the size. Initial size is like 61, right? So it's gonna be 61. Yeah, and it's gonna be like around 24. All right. So once we're inserting the value, so we need to find the index, right? So the index is going to be essentially key, and we know that the key is hashable, so we're going to do hash mod kvs len, right? And there we go, we have an index. So we also need a way to actually tell if this slot is taken or not. An intentional rhyme, by the way, an intentional rhyme. So, not really sure what would be the best way to do that. I can add another boolean, but our tuple is starting to have way too many fields in it, so maybe at some point it would be better to actually extract it to a structure. Right? So because we're starting to have way too many things. So let's actually quickly do that. Construct hash cell, right? It's going to be hash cell, and it's going to accept key and value. And here we can store key as a key, value as a value, and taken, right? Taken as a boolean, right? So the default value of that hash cell is going to be default value is going to be false, hopefully. Is this beginning of weights for us? No. What we're doing right now, we're just implementing the hash table as exercise for educational purposes. So it's not going to be really aids because I don't really use Rust that often. Don't really use Rust that often. So let me see. So what I want to do in here is probably derive default thingy in here, right? I will derive default, and so now I'm gonna just have a hash cell which contains key and value, right? So then I can initialize this entire thing with hash cell default, right? Hash cell default, and I wonder if I have to do something like this. So might as well actually do it like that. Yes. Okay. No rules exceed for token in macro. Okay, so oh, maybe I have to do it like this then. Okay, a field by this name exists in self. Oh yeah, I completely forgot that this method have to have self. Okay, so insert accepts immutable self, get accepts immutable self, and get mute accepts immutable self. Yeah, I forgot that will work on self. Actually, compiler give us a very useful message, not gonna lie. KBS cannot be formatting using. Okay, so let's remove that. Maybe it doesn't matter. Hash cell. The trait clone is not implemented. Okay, so let's make it clonable then. Oh shit, it compiles. Nice. Seems to be compiling. So we're taking the index and we're looking at the cell. So let's actually rename KBS to cells. So KBS cells. It's gonna be like this. And we're looking at the cell. Cells. Cells index. And if it's taken, if it's not taken, right? What we have to do, we have to, well, it has to be self, of course, it has to be self. We just mark it as taken, then we save the key in here, and we save the value in here. So this entire thing becomes taken. There we go. So do we need to return anything particularly useful in here? Maybe, I don't know. Oh yeah, by the way, I completely forgot one important thing with get and get mute. So you may not have a key in your hash table, so that means you have to return option reference to value, and this thing has to be also option reference to value. So that's quite important. Okay, so this is the simplest case. This is a very simplest case. It's when right, you just have a how to say that, like a free cell, and you just put a thing in there. We might as well, you know, have a special function that sort of like debug dumps the hash key. So let's do something like debug dump, and it's going to dump each individual sort of cell and tell you whether it's taken or not, right? And if it's taken, what kind of key and value it stores. So let's quickly do that. So this thing is going to accept self, and what we're going to do in here, we're going to iterate through the cells in self cells, right? And if cell is taken, we're going to print it like so. So it's going to be from key to key, and it's going to be cell key cell value. And here's an interesting thing. That means the key and value has to be printable. Well, maybe we can make them at least debuggable, right? We can make them at least debuggable. So otherwise, we can mark this sort of cell as not taken. We're going to put X in there. You see what I mean? So it's going to be just X. And let's actually make initial, like, very small amount of elements, like 11, right? Not a big one. Okay, so let's see if it compiles. Oh shit, oh fuck. And yeah, cannot be formatted because this thing is not debuggable. So key, on top of being clonable, defaultable, and hashable, have to be also debuggable. And value also has to be debuggable. I'm pretty sure I can probably tuck it under something. Yeah. And so what's going to be the next thing? Plus debug, not a trait. So I think debug is available somewhere else, right? It is available somewhere else. Yeah, maybe it has to be done like that. I don't know anything about Rust, I'm sorry. So Maybe it has to be done like that, maybe not. So we need to use stdfnt debug, right? So what are the errors? Self. Oh yeah, this thing has to be iter, if I remember correctly. And there we go. Okay, at least it compiles. Let's create a mutable phone book, which is going to be a hash table from string to string, and it's going to be new. And I'm going to put this thing in here. Phone book insert. We're going to be inserting Lexi, and this is my phone number, by the way, if anyone is interested. And then we can do phone book debug dump, and there we go. So, oh yeah, those things are not proper strings, right? String, and it's gonna be something like toString. There we go. Okay, and there's nothing in there except for the first one. So, interestingly enough, the hash calculated to something that is that hit the zeros bucket or the zeros cell. So maybe if I change it slightly, something like this, maybe yeah, now it hits a different cell in here. You see, depending on the key, it's basically gonna hit different cells. Who's Alexei? And it's just like it's in Russia, it's similar to John Doe, right? So we can also add the John Doe, just in case. Hopefully it's not gonna collide. John Doe. And I don't know why it starts with something like this. Okay, there we go. And it's actually, they're nearby. Would you look at that? They're kind of nearby. They almost collided. They almost collided. And we can try to implement get. I think get could be very, very similar, right? So we're gonna take it like that, and then we're gonna just return. It actually depends. If self cells index is taken, we're gonna simply return self cells. Benny Darshan is gifting 3 tier 1 subs. Thank you so much for supporting the community. Thank you, thank you, thank you. And everyone who got this up, welcome to our epic Rust Club. Isn't that amazing? I think it's goddamn fucking amazing. So, what we're gonna return in here, we're gonna take the value and we're gonna take the reference, right? And I'm gonna return some of that, right? We're returning some of that. Otherwise, we return none. There we go. Otherwise, we return none. So after that, we should be able to, for instance, take that value. So println is something like this. Phone book get John Doe. Right, and unfortunately it has to be to string. It has to be to string. And we can try to get a random thing in here. And let's see what's gonna happen. So this thing doesn't compile because, yeah, parentheses, of course, that's the most important thing. Oh yeah, it has to be pointer to this stuff. Okay. There we go. So as you can see, in case of a John Doe, we managed to get something, but in case of none, right, in case of like something else, we didn't get anything. So this is how we can query these values. But this is not enough. So right now we completely disregard any collisions whatsoever. We completely disregard any collisions. So for instance, when you insert something, right? So this thing, we always assume that it's not taken, but what if it's taken? What if it is actually taken. I suppose what we have to do in here is something like while self thingy is taken, we have to increment the index by 1, right? We have to keep incrementing the index. But we have to increment it really carefully, right? So because you can overflow over the amount of cells, so you have to do something like index plus 1, but with the mod of self cells, right? So that will make it go around if it reaches the edge of the array, right? If it reaches the edge of the array. So this is the first case. So we handle the first case. The second case is it may never find a cell because we don't have any cells anymore. So if all of the cells are taken, what do we even fucking do? So this algorithm will just go around in circles forever and forever. So we need to keep track of how many cells are taken, and before inserting anything, if we ran out of you made me laugh, Jay. Thank you so much. And if we ran out of cells, we extend the hash table and only then try to insert a thing there. So yeah. So that's what we'll have to do. So how we're gonna keep track of the taken cells? We're gonna just count them. Taken count, and it's gonna be just usize. I haven't seen. Have you seen Emote Jam, Lori Master? Yeah, you need to check out Emote Jam. So this is actually a pretty cool website. So you can literally upload. Oh, there is a problem, by the way. So if you put jam with small letters, it's gonna be 404. So you have to be super careful with that. So your link might not work. Yeah, it's a 404. I need to fix that somehow. This is a really shame. So one of the things I can do, I can probably create a separate repo. But essentially, you can upload any image in there, and you can apply some filters to them and turn it into animated emote, and then render this entire thing, and then download it. So yeah. Heard Emote Jam is a shader. No, it's not the shader toy yet. It doesn't have enough functionality to be called the shader toy. But yeah. If you use Cloudflare for the no, I can get HTTPS for free already. GitHub pages already provide HTTPS. It's just like the problem is that GitHub does not automatically redirect you from insecure version to secure one for some reason. I don't know why. We live in 2021 and still some website, and even as huge as GitHub, don't do that. So, and by the way, I don't have my own hosting. Everything on Sodium.org is GitHub pages, like literally everything. I just set up a custom domain. Wait a second. You get. Oh, okay. Yeah. But there was. I think I enabled it. I'm pretty sure I enabled it. Wait a second. So Emote Jam. I remember quite vividly enabling it, but it still doesn't work properly. HTTPS. It's probably not there, but pages. Oh, I guess you have to enable it for each of the sub websites. Okay, sure. I don't mind. All right. So what I was doing, yeah, we needed to count how many elements were already taken, right? So essentially, once you manage to insert a new element, what you do is do taken count and increment it by 1, right? So so this way we can make sure that we know how many of them are already taken. So now, before trying to do anything, if self-taken count, if self-taken count is greater or equal than self-cells len, we need to extend the hash table. So it's going to be something like self-extend, right? So after that, this condition should be false. So after all of this thing has to be something like this. It's quite important. If this condition is false, that means self has a bug in its implementation, right? And that's why I want to assert this entire thing. All right, so extend. Let's put extend in here. Extend. So it's going to accept mutable self, and yeah, there we go. All right. While taken index equal index plus 1, but mod this side, it's not a mod cells len, and after that we just insert another thing in here. There we go. So yeah, if we don't have enough cells, we extend this entire thing. Then we start with an index, and if index collides with anything, we go to the right until we find something, and we should be able to find something, otherwise this would be false. And then we insert that thing in there. We mark that cell as true, we set the key, we set the value, and increment the amount of taken things. So this is pretty much the final implementation of insert. So far, at least for this specific recreational educational stream. So let's see if it compiles or not. So self missing, yeah. We also have to do something like taken count, and it's going to be initial 0. And as you can see, everything works so far. We can try to... Oh, this is not the final one. So there is another interesting problem. So what if you insert the same key but twice? What's going to happen? The same key but twice. So both of them are going to be inserted, and the keys are not going to be unique anymore. And I think our insert has to take that into account somehow. There are multiple ways to take that into account. So if you insert something that is already taken, how this thing should react? Should it act like it's updating, or should it throw an error? How does standard hash function does that? Hash map. Let's actually find out. This is a very interesting question. So it's going to be insert. Oh, it returns an option. Inserts a value key pair. If the map did not have this key present, none is returned. If the map did have this key present, the value is updated and the old value is returned. The key is not updated, though this matters. Okay, this is actually a pretty good idea. So insert may act as update, and we may return the old value. Let's implement it like that. Why not? I think it's a pretty good idea. So, and it actually returns it by value, so it sort of disowns it. That's very interesting. So when you insert a value, you move it inside of the hash table, and when you insert a new one, it gets substituted, and old one basically moves out of the hash table with the move semantic. So you move in a value and move out without actually copying and stuff like that. You see? Something that works in C without any problem. So basically it acts like C in 1970. Anyway, I'm sorry. So my favorite take is that we had move semantics since 1970, then it got broken by C++, and then it got fixed by C++ yet again in C++ 11, but in a scuffed way. I'm just joking. I mean, the situation is even more complicated than that, but it's sort of it's kind of a joke. Anyway, so what I wanted to do. So the thing we can try to do here, we can try to get the value first, right? Something like, okay, if let some old value equal self get mute key by a pointer. So if this thing exists, so this is an old value. This one is actually very interesting. So maybe we have to move it into the result in here. So this is going to be old value. This one is interesting. How do you disown it then? How do you move it out? I don't think you can move it out. You'll have to copy it. You'll lose it. You cannot just move it out. Yeah. So you literally have to copy it. Let's not return the old value now. Let's not return the old value. So in here, I just take the old value and I set it to new value. Right, and this is going to be the new value. Okay, and otherwise it's going to be like this. All right, so if you have this thing already in here, right, you replace the old value with a new one. And what's cool is that you don't even have to update anything. You don't have to update take count, you don't have to update taken, so you're just replacing the old value with the new one. If this thing never existed, we just find the first one and we just put it there. So yeah, that's pretty much it. All right, so if you try to run it now, yeah, so this one is a new value. So, and now it actually crashes because to insert a value with the same key, right, if you have a different key, it will work just fine, probably. Oh, yeah, it still needs to do that. So it's not going to work because the first thing it tries to do, it tries to find that value in there, right? It tries to find that value in there. So we need to implement getMute, but getMute is pretty much the same as get, right? Except we need to repeat the entire idea of, you know, iterating to the right until we find the actual value. You know what? I think I want to make a small break. And make a cup of tea and also pee and stuff like that. So no, I think I'm gonna remove it right now. So I'm gonna start over. I think. All right, cool. Does anyone have any questions while I'm making a cup of tea? Anything about Rust, hash tables, programming? Is there anything you want to ask me? You can move it out with memreplace, but doesn't memreplace actually copies the data, like on a hardware level? I think it does. So I want you to avoid copying it all for some reason. I don't know why. There's no particular reason to avoid copying it all, but I just wanted to do that. And for some reason in my head it made sense. And I suppose memreplace like physically copies the data anyway, so I just thought, what's the point? Moves src into the reference, returning the previous destination. Neither value is dropped. If you want to replace the value, well, yeah, to move a value under particular reference, right? So if you imagine RAM, right, you have array of bytes and pointer points a particular beginning of the memory. How you move replace a data under a certain pointer. You just copy that data there, so you still copy things, right? So I don't know. I wanted to avoid specifically that, but then I realized that it goes into conflicts. How do you handle collisions with the open addressing? All right, so let's listen to some music. Do you guys want to listen to some Kikono music? I wonder if the spammer is just waiting for me to actually go on a break and then they're gonna strike. So yeah, I'm gonna mod someone else as well. So Sarimon, you're a mod now. All right, so 3 minutes. Let's make a small break, and you guys have fun. Yo, what's up? Move semantics is technically copying the data. Well, yeah, depends on what kind of data, right? Usually when you move something, you would copy less data than you would have been if you actually copied the entire thing. It's not a useful conversation. All right, so I'm waiting for my kettle. And does anyone have any other questions, maybe? So what we need to do in here, we need to do a similar thing in get as in insert, right? So we take an index, right? We take an index, and while self cells index is taken, right, while this thing is taken, and self cells index key is not equal to the key you provided, right? So we found something, it is taken, but the key of that thing is not equal to the key we're looking for. While this kind of thing is true, we are incrementing index in the same fashion as we do in insert. Cell_slam, there we go. So, and then after that, we either found nothing or we found the gold. That's right. And after I pour myself a cup of water, I'm gonna be back and we're gonna find the gold. All right. All right, so if self cells, well, there could be another interesting thing. What if at this particular what if at this particular point of time all of the things are already taken, right? All of the elements are already taken. And that may happen because after we insert something, like after this particular action, all of the cells might be taken. So, and it's not until we insert another time the hash table will be extended. So there is a period of time when you may try to get mute and it's not going to be extended whatsoever. So I see two solutions in here. We either check this condition. Also after this entire thing, or we do something to this iteration. We can try to limit the amount of times this entire thing is iterated. Yeah. So we can limit the amount of times this entire thing is iterated, and if through this amount of times we haven't found anything, oh, there's a third solution. There's always like a third solution. You can just try to extend it on get mute. Why not? So get mute now extends the table, which is a very interesting idea, not gonna lie. Which is a very interesting idea because it might eliminate this step, right? Because in insert, we do get mute anyway. So this might not even need it ever, right? So because you call get mute, it will check if something, if you have enough elements, and at this point is going to be that. That's actually a pretty cool idea, not gonna lie. Huh. All right, so what do you guys think about this idea? Actually, check for the table overflow in get mute instead of insert, because you do get mute and insert anyway. If you use get mute and insert, it just depends on implementation. But in this particular implementation, I think it's pretty cool. Never thought about it. Like, I haven't implemented hash tables for quite some time, so it's kind of cool to revisit all of that and just rethink this entire stuff. But I think it's pretty cool, right? I think it's pretty cool. So we'll see how it works out. Anyway, so get mute, we check that the amount of taken is not overflown. If it's overflown, we extend it. Then we are looking for something. We know that it will stop at some point. Okay, and now if this thing is taken, right? This thing is taken. That means the key is equal to the original key. It must be. We might as well even assert that. We might as well even assert that. That's very important condition here. So, and in that case, we're gonna return some cell, but we're gonna take it by a mutable value. We're gonna take it by a mutable value. Otherwise, if it's not taken, there's nothing to return in here. We're gonna return none. We're gonna return none. And let me try to build this entire thing and see if it builds, if it still builds. Cannot be applied key. Because this thing is a reference, so we have to dereference this entire thing. All right. Cannot be applied to key. So key has to be clonable, defaultable, debuggable, hashable, which is our custom trait because we don't want to use the hash trait from the standard library, and also partially equal because we want to be able to equal these keys. All right, so let's quickly do that. So let's use stdcmp partial eq. So it's going to be partial eq. So it means this thing is going to be plus partial eq. Luckily, we don't need to do the same for value, right? We're not comparing the value. Yeah. All right, so, and this is not enough. Well, I mean, it's almost enough. We have to do something like this. And then we return, so value found hash cell. Oh yeah, I have to do something like value. All right, there we go. So mutable is implemented. So this is basically what we have to do in mutable. But the problem is we need to replicate this entire stuff in get. And I wonder, in Rust, if I have a mutable reference, can I sort of downgrade it to an immutable one? You know what I mean? I wonder if it's possible to do something like self get mute, like this. Is that a thing you can do in Rust? Differs in mutability. Yeah, you cannot just do that. So let me actually research that. That would be actually pretty interesting. So Rust mute reference. Maybe let's call it cast. I don't think cast, if cast is the appropriate word in here, but cast mute reference to immutable reference. So do people even discuss how to make Rust mutable reference immutable? Okay, so let's see some discussions of some people. Dereference the re-reference. Oh, okay. All right, so that's very interesting. So I can map this entire thing. I can take the value, I can dereference and reference it back. All right. Oh shit, didn't work. Self is as mutable. It is. Oh shit, you cannot do it like that because self is okay. Very interesting. How technically, because I don't want to copy paste this entire stuff, right? So because you really don't want to copy paste it. Sometimes you wanna. Okay, so how are the other implementations usually do that? Let's find out. Because I'm not really familiar with Rust, so I'm not sure. So it's gonna be hash map collection. So it's gonna be get, and let me take a look at the source code. So how do they usually do that? Base get. So there's something called base, and I wonder what is the base. It's all about that base apparently. So it's probably something inside of this thing. So base, there is like a hash map underneath this entire stuff. So do we have an access to the base? Do we have an access to the base? Is it std base or is it something? It could be like internal module. Yeah, it could be internal module. Let's actually take a look at it. So, oh, okay. Hash brown. G, do you see this shit? Speaking of hash brown, what the fuck? That's very interesting. Okay, hash brown. Apparently, it's some sort of. Is that a crate? Is that an existing crate of some sort? Hash brown. Hash brown should implement this method. It could be some sort of like a crate that they're using. Okay, can we have an access to that crate? Hash brown. Okay. Okay, a Rust port of Google's Swiss stable hash. Oh, it's a port at least. Okay. That makes sense. So they basically wrapped a port of Google's Swiss stable or something. Interesting. Interesting. So, all right. So here's the map. Oh my god, it's pretty big apparently. So struct hash map, and it has a fn get, I presume. So it gets avoid option map because it bloats LLVM IR. So there's a get inner, and so it's a reference. And what is a get inner? Okay, that makes sense. But it still returns immutable one. That's what's interesting. So what about a fn get mute? A fn get mutes has a fn get inner mute, and a fn get inner mute. Okay, it uses like self table struct hash map. So row table. Okay, so we need to penetrate another layer of indirection in here. So where is the row table is defined? Row table is defined in create row. Okay. So I guess we went full circle, didn't we? So is there something like row? All right. Row. Contains struct definition for the layout of compiler. But it's actually kind of. I see, but maybe it's a. Oh, okay. It's a part of this thing. All right. Everything's fine. So do we have a? What was it called? Something like table. I forgot the name. Table. Just a second, I need to go back. I actually lost a little bit. Because I went too many stacks of the too many frames of the stack. Get mute. All right, it's a get mute. Get inner mute, and we use table, and table is row table. Okay, it's called row table. I forgot the name of this thing. It's a row, and what we're looking for a row table, right? We're looking for a row table, and so here's the row table, and in here fn get mute. Da 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 da. Holy fucking shit. I was thinking, how do they reuse const and non-const version. They fucking const cast it. Am I missing something, or is it really how people do that in Rust? Please tell me that I'm an idiot. Please tell me that I'm an idiot and missed something, I misread something. So... It's not a const cast. Why? Because there is no word const in there and there is no word cast in there, right? Do I understand that correctly? Let's take a look at the as mute, actually. So is it part of this thing? Oh, yeah, thank you. So I was an idiot. All right, right. So this thing is, well, no. But find returns append find. Returns
TFW Zozine Stravau Hashmap is Cypher Tanesti Delete.
So find essentially takes the immutable reference, right? So the fact that you have to do as mute, it's sort of like bypassing the type system of the... Well, I mean, technically, it's not a const cast, but it's not better, in my opinion. It's like it's... Overall, the entire thing works out quite well, because at the end of the day, you accept mutable self, but then you're forced to use find that works on immutable one and returns you immutable thing that you're then forced to do as mutable and also mark it as unsafe. So overall it works out nicely, but you have to put these hacks to work around this entire like type system. You know what I'm talking about? You know what I'm talking about? It is not bypassing anything. Well, it's bypassing the fact that find has to take as immutable, does it not? I don't know. What? So it returns a bucket, returns an option. And it's also unsafe. How is that bypassing anything if it has to be unsafe? I don't understand. I don't understand. How is that not bypassing anything? It returns an owned bucket. I understand. Why is it unsafe though? Let's take a look at the bucket. I think we need to take a look at the bucket. Struct bucket. Is it pointers? Okay. Info for bucket. I think it should be implemented somewhere as mute. I guess it depends on the definition of bypassing. So I think Freezy09, by bypassing, you and I mean different thing, and we cannot bear a conversation because of that. What do you think? Because, like, what do you mean by bypassing? When you say bypassing, what exactly do you mean? Says find the pointer is defined from mutable reference. But you didn't answer my question, so you don't want to continue conversation, right? For me, this is basically bypassing the limitations of the type system that was put in place. So yeah, basically the type system introduced a lot of friction, and to get rid of that friction, you have to do this kind of stuff. Right, so for me it is bypassing. For you, bypassing means something else, and that's why you continue argue with me. So, and that's why I'm interested in what exactly do you mean? So, yeah, so for me, it's bypassing. Like the type system introduces a lot of friction, and you have to do this kind of stuff. So the same problem exists in C++ as well. So, yeah. You need to bypass even though your code is probably... Yeah, that's exactly what I'm talking about. Limonade, you're right. I absolutely agree with you. So at the end of the day, it works out safely, yes. But you still have to work around this friction. Man, unsafe and Skype, I don't explain it easily in the message. I'm not trying to convince you that this is unsafe. Freezy09. I actually explicitly said, yes, it is safe at the end of the day. Can anyone confirm, did I explicitly say that, yes, I do agree that this entire thing at the end of the day is safe because we own everything and like we know what to do? My point is completely about a different thing. Like, I'm talking about completely different thing. The same problem exists in C++ as well, believe it or not. This person doesn't listen to me. This is beautiful. I absolutely love it. They ignore everything what I say. And they just argue with something else. This is incredible. Yeah, I absolutely love when people just ignore everything I say and argue with the points I never made. It's just, it's my favorite. Thank you so much. All right, very well then. So let's continue. Don't you love? Well, all of your points are fucking thrown out of the window. I absolutely love it. So, to be fair, this kind of problem of reusing the code for const and non-const versions of the getters setters is kind of hard, and I still personally don't know how to solve it. And I think if people knew how to solve it, it would have been solved a long time ago in C++ and Rust. It's just like I'm a bit disappointed that Rust didn't even make an attempt to solve that. And I think C++, I remember Gia actually said that C++ made an attempt to solve it with something like similar to... You mentioned like things no except or whatnot. I don't know. All right. Oh, it could be a way to approach it. Oh, okay. They haven't done that yet. Yeah. So, but what we're gonna do in our case though, what we have to do in our case. So in our case, we can just simply copy paste it at least. I don't know, but every time you'll have to update this kind of stuff. Did I already close the code? I think I already closed it. So here is the bucket. Wilkins, thank you so much for 19 months. Thank you so much for not 1910. I have a really bad vision. Thank you so much for 10 months of tier 1 subscription. Thank you, thank you, thank you, and welcome to our epic Rust Club. Make a generic helper and pass T. Come on. Come on. We have a solution in front of us all along. Key value. Gee, you don't understand. Unsave is hard. Unsave is hard. I can't understand you. I can't explain you that easily. It's hard. Alright? But it's gonna be safe. Okay. So what we're gonna do in here? So as mute. So returns T. So I think I'm gonna actually return a value in here. So it's gonna be takes a self. It's kind of strange that it takes a self and bucket. What bucket contains? Bucket contains a pointer. It is basically what it is, and then as a pointer. As a pointer. So I'm thinking what's going to be the easiest way. Mams2K, thank you so much for Twitch Prime. Thank you, thank you, thank you. All right. So I wonder how we can do all of that. So I just want to try this solution. So and see if it's going to work or not. And see if it's going to work or not. But maybe. You know what? We can try to do something like this. Return self. So we accept mutable self. Is it possible to convert pointer? So I'm gonna just try this thing, Rust. Convert reference to pointer. It's possible to cast type reference to a raw pointer. I think they're casted automatically, right? So they're sort of overloaded. But I don't remember precisely how to cast them. Yeah, you have to do as like const or something. So nah, it's probably not gonna work out that really well. Okay, so I'm not gonna play with that because I'm probably gonna spend more time figuring it out than needed. The easiest thing in this particular case to do would be to copy paste this entire thing, right? So let's just copy paste it. All right. Let's just copy paste it for now, at least. So self extend. Oh, and self extend actually cannot be extended because this thing is mutable. This thing is mutable. So this idea of, you know, automatically extend it when you try to get mutable is not going to work out really well. So the extension has to be done actually outside. So actually extension has to be done somewhere here. Okay, that was an interesting shot. Let me now go and just copy paste this entire thing somewhere here. So we'll have to abandon this entire idea of get mutable automatically extending everything. Unfortunately, that would be cool. So let me do that, but it just makes it not copy pastable, right? It just makes it not copy pastable. So what are the other things we can do? The other thing we can do in here, right, to make sure that this loop is not going to repeat forever, is limit amount of iterations, right? Limit amount of iterations. How can you limit amount of iterations? Well, you wanted to make at most self-len iterations, right? This is how many iterations you wanted to make. So So let's try the following thing. For I in 0, self sells len. Self says len. So this is basically will ensure that it will make at most self like this amount of iterations. So we want to break out of this entire loop if self sells index is not taken, right? Is not taken. We're break out of that loop. So this is going to be break. And if this key is equal to itself, right? If this thing is equal to the key, we break out of that. All right, so this way, this loop is not going to repeat forever, right? And it doesn't require extension or anything like that. So also, every time we finish an iteration, we have to increment the index, right? We have to increment the index. So, all right. So after this thing, if this entire thing is taken, and I suppose and the key is equal to itself, and we don't need to assert that, we're going to return this entire thing. Otherwise, we're going to return none. Here's an interesting thing. I think we can abstract that away by making something like get index. This is so goddamn fucking funny. This is so fucking funny. Gia, do you understand what I'm about to implement? So it's the same shit as with linked lists. You basically bypass borrow checker through indices. All right, so okay. And in that case, you just return an index like this. And essentially, get mutable in that case is going to be, oh boy, get index, right? So it has to be self, right? Key map, and this is index, and essentially it's a self, sells index. Value, and you gotta get it by mutable. Okay, so okay, so you have to use indices. This is how we do that. All right. Okay. Expected enumeration, yeah. So this, it's a semicolon. It's a semicolon. Okay. Yeah, this one is unused. And what else we're gonna have in here? It's probably not gonna work. Self may outlive. Oh, okay. So that means we have to actually say that the lifetime of these things is gonna be this. And declared lifetime. Okay, so can I just do something like this then? Self is borrowed. Index may outlive. Index. How can it outlive? I don't quite understand. I don't think it can outlive. It's an index. It's copyable and shit like that. It doesn't make. Wait. Does it complain about different thing? I think it complains about different thing now. No, it complains about the same thing. And it only complains about the mutable version, right? So it only complains about the mutable version. So it doesn't complain about immutable one, right? So, You still need immutable one anyway. Okay, so let me quickly do something like this. All right, it's going to be a to-do. It's going to be a to-do, and all right. So something specifically about mutable one. I'm not sure because this one is taken as mutable. Okay, what if I get rid of the map? Maybe the problem is something with the map. If let some index is going to be equal to this, right? It's going to be equal to this. And then in here, we're going to just return self cell. Maybe we have to clone something, but I'm not sure what yet. So we're going to figure that out a little bit later. So this entire thing works. So it works with the mutable one, but it doesn't work with the mutable one. So that's very interesting. So probably not going to solve anything. So let me see. And it's solved everything. All right. Okay. Nice. What do we have? It probably would make sense to maybe have identical code in here, right? Let's have identical code in here, but in here it's going to be like this. You know what I'm talking about? You know what I'm talking about? Yeah, so now we do that through the index. Can I just put underscore in here? Will it work? Yeah, it does work. Okay. So do I have any holes in my logic? Okay. Oh, we forgot to implement extended. All right, all right. Forgot to implement extended. So how are we gonna be extending all of that? But frankly, this should be inferred that self is not borrowed anymore since you own the result. Oops. Sorry. Language did an oopsie doopsie. Okay. So what we're gonna do in here, so we need to extend. My idea of extension was to essentially create a new hash table, right? Something like new self is gonna be hash table, right? Maybe I can even do something like this, just create a new one, but with the capacity, with a completely different capacity. So it's going to be self cells len, and what I'm going to do, I'm going to actually multiply this capacity by 2. There is one important thing in here, is that the capacity may not be equal to 0. Right? Otherwise, this entire expression is basically will do nothing. If it's equal to 0 for whatever reason, right? So you cannot extend anything. So, but since there's only one way to create a hash table, it should never be equal to 0. But who knows what may happen in the future when this thing is modified and updated and stuff like that. You know what I'm talking about, right? So it's better to assert that just in case, because that's the assertion we're making. All right. So another thing, taken count, right? So taken count is 0. So we have a new self. Right, we have a new self, and one of the things we want to do in here, we want to iterate through our cells that we exist in here. For cell in self cells iterate, right? And if cell is taken, what do? We do new self insert cell key, cell value. And that's it. So basically insert all of the keys and values in there. All right, so after we did all of that, I wonder if I can just simply do something like self and just move it into this thing. I wonder if it will just work, or do I have to move that somehow? Let's see. I don't know. Maybe it will, maybe it will not. Okay, cell key move occurs because... Oh, okay, so we have to actually clone this entire thing. So this thing has to be clonable. I think they are already clonable. We already indicated that they are in fact clonable. And yeah, you can just do that. So this is how we're going to extend all of that. This is how we're going to extend all of that. All right, so I guess that is it. So I guess that's what we have in here. So I want to have an access to initial capacity outside of this thing. So easy clap HD, I don't know. Let's try to insert something in this thing. So I'm going to iterate through 1 to 11, right? And I'm going to do phone book insert format, something like this I, and the number is going to be maybe format, something like this. Can I do something like this? I don't remember. Is it allowed in Rust? Not found. Oh yeah, I should have actually made it like that. Okay, so and let's do phone book debug dump. And did it do? Okay, so just builds. Let's try to run it. And yep. So we populated it. We actually populated it. Interestingly, it actually worked out. So what if I try to now add another one, right? Phone book. So I can actually dump them like this, and I just want to see how it's going to be extended, right? Maybe phone book insert. So it's going to be toString. Right. So it's going to be Alexi. And we're going to put something like this in here, and I just want to see how it's going to get extended by 2. I'm not even sure if extended extend. Do we actually extend? Yeah, we multiply by 2. I'm not sure if it's a good idea generally, but maybe it is. And I forgot a very important thing. I forgot to print what we've got afterwards. Yep, I think it worked. I think it kind of worked. Right, so it got extended and all of these things were reinserted back into the table. We can do another interesting thing. For instance, we can verify that we can still query all of these things. So now, I want to query the number name and get the corresponding phone number. So we're going to do like this. It's going to be phone book get. It's going to be format I. Let's actually put this like this. It's going to be name format I, and it's going to be format name. And we probably want to print it like this. It's going to be something like this and something like this. Phone name get name. Well, we can always unwrap, right? Because we expect them to exist. And I guess we're just gonna be printing them. Yeah, I guess we're just gonna be printing them. Format string. Oh yeah, so probably have to maybe unwrap. Expected string found string. Ah, okay. It's gonna be something like name and aborting due to previous going for a string, but found one. Ah, yeah. So it has to be now name. All right. Okay. So this is the result of querying of these things after the table has been extended. After the table has been extended. All right, seems more or less correct. Seems more or less correct. Is that a good idea to actually extend the table by 2, or you have to use something else? So is there any good practices on extending the hash tables? I've seen some implementation have table of prime numbers. We can probably do that as well. So, but if you ran out of prime numbers, what do you do? So n+1 to have a higher chance of hitting the prime. It's not a bad idea. It's not a bad idea. Thank you. Let's try to do that then. All right. So benchmarking. Not really sure about benchmarking though. So because I'm already streaming for 2 hours, so what would be a good benchmark? How to benchmark a hash table? Benchmark hash table. Is there any good benchmarks for them that we can steal, for instance? Insert access with varying probability int. So I think that's exactly what we want. All right. So we have this benchmark has been adapted from Attractive Chaos code. It basically contains the main part. All right. So we iterate several times. Then we take an RNG. We're randomly hitting this thing and just incrementing it by 1. Okay, so that's actually a pretty cool idea. So maybe this is going to be our benchmark. Because that's the only thing we implemented here anyway, right? We only implemented the insertion and get. So yeah, let's quickly do that. Let's try to benchmark this mother flipper. So to benchmark this mother flipper, right, so we're using numbers, so it's from int to int. So what we're gonna use in here, I don't know, i32 to i32. Let's give it a try. So this one is gonna be our hash, right? So this is going to be our hash, and we're going to be iterating for in 0 to, let's actually do something like 10, right, for now, and let's try to implement all of that. You know what I'm thinking about? What if we implement get mute? Maybe it's not a good idea. Yeah, let's implement it like this. So if hash get mute, right? Hash get mute. So how do you do random in Rust? Oh shit! In Rust you have to use a separate crate. Yes. Well, I mean, is it part of the distribution? I think it's a part of the distribution, right? I think it is in fact part of the distribution, so we have to use something like rand or whatnot. Rust rand. Is that the crate I have to use, right? So is there any example on how to use this thing? So probably here's examples. Monte Carlo. Okay. Oh, you have fucking C++ bullshit. You have to have a distribution. Then you have a device, and fucking shit. What's up with all of that? Like sometimes you don't need a cryptographic like a random generator. Sometimes you just want to generate random numbers. Oh. What the fuck is wrong with people? I don't understand. Feature STD RNG. Huh. Yeah, by the way, I didn't check if it has a random in the standard library yet. Rand. You have rand? So it's a random state. No, it doesn't have it, so we'll have to use that thing. I don't really want to do that. Don't really want to do that. And all features STD or something. Do I have to do it like that? Do I have to do it like that? I don't like that. Alright, so let's give it a try. So I'm gonna spend some time first learning how to use this library and only then finally using it. Thank you very much. Alright, imagine like learning how to use a random library. Okay, cargo build. Is it gonna download this thing first? I mean, yeah, C random number generator was simple. It was not like maybe cryptographically strong or anything, but sometimes if you want to prototype something super quick and you don't need like cryptographic strength or anything, you just grab that thing and start using it. It was just amazing. Hash table is never constructed. Okay, so I'm not really sure what this stuff means, so I'm gonna just ignore it. So it's gonna be a range uniform, blah blah blah. And we want to sample this RNG and just see what's gonna happen. Print ln. Right, it's gonna sample like that. We're sampling this RNG. And is it gonna print anything? Okay. So did it? Oh, I just built it. Okay, I wanted to run it. Okay, and it gives me. Okay, so we do a new uniform. From -1 to -1 to 1, right? Okay, let's do 1 from 0. Can I do something like from 0 i32 to i32 max? Is there such thing as max value of this thing? Can I do something like this? Rust i32 max value. Where is it located? It's called max. Okay. Oh, right, that's beautiful. So you can just do, okay. Thread RNG. Like, what the fuck is thread? Why does it have to be thread? Okay. We're doing multi-threading now? Or is it a different kind of thread? Okay. Retrieves a lazily initialized thread local. Okay. Oh, okay, it makes sense. So it's not multi-threading, but it's a thread local in case you start doing multi-threading, so different thread is going to have its own state of RNG. Okay. All right, that makes sense. So, and there's also random. T has to be a distribution. Generates a random value using thread local random number generator. Do you have an example? Oh, you don't even have. Okay, probably I looked at the wrong example. Okay, I was looking at the wrong example, so that means I can just do random So you don't need any of that. So you do have like just simple shit. I like that. All right. We do have some simple shit. Cannot be chained. Yeah, sure. Cool. So that's exactly what we're gonna use. Finally, I learned how to use this library. Okay. So do I need to save it to as key? I think it would make sense. Just save it as a key. So we're gonna take the key, and if we found the value, right? If we found the value, we're going to increment it by 1. Otherwise, hash insert key 1. So because it's basically 0 plus 1. The function says a new exists for struct trade bounds not satisfied. Oh yeah, we need to have a hash for this thing. Okay. So implement hashable for i32. It's going to be just fn hash use self use size. So the question is i32. Now what? Okay, so okay, cool. So if I try to maybe debug dump use, so we even, oh okay, so some of them are not even taken. All right, so how about we do that hundreds of times? Yep. So that's the table we've got, and we didn't even have that many collisions. That's what's interesting about it. We didn't even get that many collisions. What about, oh my god, I'm gonna regret that. We didn't have a single collision? Is that true? 1,000 random values, not a single collision. Okay. Well, I mean, they're random and beacons, stuff like that, so we might not even get any collision whatsoever. Well, I mean, it's not about there will be no collision, so they're going to be incremented by 1 only if one of them ever repeat. So they might actually have a lot of collisions in here, in fact. Okay, so let's not print them. Right, let's not print them, and let's just wait 10,000 of them. Okay, so what about 100,000 of them? Okay, it's doing something. It's probably consuming a shit ton of memory. Probably consuming a shit ton of memory. Yeah, it's already struggling. So it's already, but it actually finished. Okay, so Rust benchmarking. Rust benchmarking. So so we have mod tests. Do you have to have, so Rust supports benchmark tests which can test the performance of your code. So let's make our own. I don't think this is needed. So okay, let's put this thing in here. So we're gonna have a bencher, and let me put that thing in there. Bench, bench our Pepega table. Right, so this is what we're going to try to do. We're going to try to bench our Pepega table. All right, so can I bench? Holy shit, it's going to download more dependencies. Bencher, very annoying. Yeah, same. Rand cha-cha. Use of undeclared crate or module test. Okay, cool. Is that because I need to enable feature test or something? I don't know. So, let me see. Useless. Okay. Cargo bench. So, we need a proper example. This is not an example though. This is not an example. I need a working example. Unit tests and benchmarking in Rust. Okay, let's open slow as medium article and read more about it. Okay. All right. Isn't that what I do? What did I miss? What did I miss? What's some small thing I missed? Do I have to add something to the in your attribute? Okay, so this one is not needed. I missed something that's very, very dumb. Undeclared crate or module. Oh, maybe I have to add the crate. Yeah. So it has to be crate tests or something. No. Do I have Tomo? Cargo. Bench. I don't know. Why there's no a single example that just works? Like, I just want to work an example. Use undeclared create a module. So there's no test module apparently. Okay, so let's try to do something like Rust tests. I just want an example. Like, I just want to work an example that I can just follow. But yeah. Okay. All right. So I did that. Sure. Cargo that should just work. Okay. But benching doesn't work. So if I, yeah. So if I replace this thing with test and say that we don't have a bencher, right? So if it's a regular function, maybe I'm dumb. Well, okay, so testing work, but benchmarking just doesn't work. So bencher does not exist there. Oh boy. So people recommend something Criterion or something. Maybe that's what I have to use. Fucking changes everything every like year or something. Examples. Show me examples. Okay. So how do I run it then? Bench my benchmark. Okay. Main. So Yogit Ozdemir, I hope I pronounced your name correctly. Thank you so much for Twitch Prime subscription. Thank you. And welcome to our epic Rust Club. So it has to be a separate program with its own entry point. Do I understand that correctly? Just using the bench thing that I used to use a long time ago was way easier, so now it is more complicated. All right, so okay, we have this thing, Criterion benchmark. Okay, I'm fine with that. Of course, this kind of shit has to be overcomplicated. Otherwise, it's not cool enough. All right, so let's see. Rust measure execution time. duration calculation. All right, so all right, so now this is how we do that. So it's gonna be called begin, right? It's gonna be called begin, and then we're gonna turn it as seconds, but we'll also probably, nah, I should do it. Okay, so let's see. Okay, so let's try to run this entire thing. And see how much time it will take. Seconds. But can we actually do seconds? Milliseconds? So now seconds is integer, right? So duration, let me find it. As sex. As sex. Oh, funny. I'm 13. Haha, sex. So millis. Okay. You 128. As millis. Let's just try millis, I think, because I want to like a little bit more precision. We can always like turn. Oh, there's div. Oh, as sex. But F32. Yes, that's what I wanted. F32. Cool. Yeah, let's fix that over there. $16 seconds. Okay, so let's create a function. Benchmark our Bebega table, right? And we're gonna accept the n, which is useSize, and it's simply gonna do something like this, right? Let's include this entire step. Let's actually call it our virgin table, and then benchmark std chat table, because I'm pretty sure it's gonna be fast. Because if I understand correctly, right, so the Rust hash table is a port of Google Swiss table, which is their own hash table, and at Google they only hire like top MIT students, and I'm pretty sure top MIT students know how to implement a fucking fast hash table. Let's be honest. I won't be able to beat MIT students, alright? Some hobo from a Siberian forest won't be able to beat MIT students. Okay, so this is gonna be n, and let's see. And in here I'm gonna be using, I suppose, can I actually use like internally use std collections hash map? Yeah, should be alright. So it's gonna be hash map, and I think like in terms of insert and get mute, it has the same interface pretty much, so it should be alright. So benchmark our virgin table. Okay, let's put n in there. So it's gonna be const an use size. By the way, can you do... Why don't they have number literal separators? Rust number literal separator. Literal separators tokens. Okay, something. Underscores can be inserted in numeric literators to improve. Yeah, that's what I'm talking about. Why did I think it didn't work at some point, or I'm an idiot? I think I'm an idiot. Okay, so let's put it like this. It's gonna be that, and std chat table. Okay. Alright, and alright, so it's working. Let's see how much time it will take. So ours takes 16 seconds. 60 seconds, so 17. Well, I tried. Alright, so can I do a release one? Let's see what's gonna be in release. Look at that. Okay. 2 seconds. I wonder if I can improve the speed by like using only, you know, prime numbers. So let me think. It's too much effort. Okay. So I'm gonna do something like this. Release. So we have a bunch of stuff in here. So we don't use duration apparently. Okay. What else do we don't use? Yeah, this one is also gone. So get. So let's actually allow. What is that? Allow that code, right? Allow that code, and this one is allow that code, and this one also. Okay. So what I'm thinking is that what if I put it inside of a module, right? And if I put it inside of a module, I have to make everything like public and stuff like that. It's probably gonna be super painful, but yeah, let's give it a try. So it's not gonna even compile. Pepega. Yeah. So let me just now go. Okay, hash table use Pepega. Hash table, yeah, hash table has to be public. This thing has to be public. So let's go through methods and decide which ones are going to be public. Right, which ones are going to be public. So this one is not going to be public. This one is going to be public, and this one is going to be public. Private interface. Okay, so let's make this not private. Get is still dead. I was hoping that if it's in a separate module and you mark it as public, it sort of becomes part of the public interface, so it won't complain if it's not used. But I guess it analyzes it for every, for the entire program. Like it analyzes it for the entire program. Okay, fair enough. I guess maybe for get, I don't want to allow. Okay. Allow that code for this specific one. But yeah. So let's also add something like our virgin table, std chat table. Okay. Oh, and of course I forgot. I'm an idiot. Why am I so bad? I'm really bad at programming. All right, so this is the first commit, by the way. Ready, set, go. Yeah, so that's the implementation of, like, you know, very dumb implementation. Is there any way to compress this entire shit? Can I don't even know. So if you have something hashable, yeah, do you guys know any ways to compress this a little bit? One way I can see is maybe put it into the hashable. Right, so we can try to put it into the hashable. Okay, so I remember that Rust also has a where keyword. So is there any examples of this thing that we could use? Yeah, this is what I'm talking about. For this, where, yeah. So essentially what we would be able to do is do something like that, where key is that, so we can just keep the key like this, and where value, do we separate them? Yeah, you separate them by semicolon, and then you just have it like that. And maybe we can also do Rust format buffer. Yeah, this is how we do that. Yeah. So if you have a lot of these things, you can just move them like down there. I guess makes it a little bit more readable, probably. Okay. Okay. Improve formatting. Okay, let's actually upload that to GitHub. So Rust hash table. So it's going to be readme. Purity hash table implementation in Rust. It's going to be public. And let's create a repo. Okay, chat, look. I uploaded my Pepega code. I uploaded it. I'm not afraid of it. I don't know anything about Rust. I'm being completely ignorant about Rust. I write completely ignorant code in Rust, and I'm still not afraid to publish it for everyone to learn and laugh at me. Yes. So, but maybe it can be useful for somebody, and maybe my entire thought process that I showed you on the stream is useful for somebody who's learning Rust. I don't know. So was it interesting? By the way, maybe there's a couple of things that I wanted to document. For resolving oh, thank you so much for 100 bits.
Where is the juicy GIF? What kind of rhythm is this?
Where is the juicy GIF? What can we put there? Hash table. there's nothing interesting with hash tables. It's kind of boring. Okay. Thank you so much for 100 bits. Thank you, thank you, thank you. Crab emoji. Okay. Wait. Let's close all this shit. Oh, it's so satisfying. I'm closing all this shit. All right. Rust Ferris. Yeah, I like this one. So they use this image of the Ferris when they're referring to unsafe code, as far as I know, in their book. Oh, thank you so much, Hiyosha, for 100 bits. Thank you, thank you, thank you. So, save. Save as unsafe SVG. Sodium emojim. And save SVG. Holy shit, it is small. Oh, it is absolutely broken, by the way. Okay, so if I try to open unsafe, is this because it's so big? It could be. Okay, let's convert unsafe SVG to unsafe PNG. We might also try to... Oh, it's taking quite a bit of time to do that. Safe PNG. And it doesn't have a transparency. That is annoying. That is very annoying. Convert SVG to PNG transparency image magic. Convert with transparency. Okay. Show me what you got. Background known. Okay. Did they? Okay, it doesn't work. All right. Or maybe it will work for me. We'll see. Okay, it worked. Yes. Okay. Copy and save. By the way, Cerimon, thank you so much for implementing that download button. It's a fucking saver. Yes. Alright. Unsafe GIF. Okay, for resolving collisions. How do you spell? Is that how you spell collisions? Yeah, collisions. We use open addressing. For the hash function, we use DGB2. Is it called DGB2? Yeah. Yes. So, and in Wikipedia, yeah, so this was pretty much the only reference. To be fair, not really. So we actually had several references. So open addressing. And the second thing that we used in here is the hash brown. So so that's the second reference that we use, right? So I looked into the Wikipedia and then I also checked the implementation of hash brown. That was actually pretty educational. I learned a lot, and I really liked it. All right, so okay, improve readme, and I'm gonna push that right into the repo. Oh, my mouse is dying. I need a new mouse. So Rust hash table. Okay. So this is the result of today's stream. Purely for education and recreation purposes. For real world production, please use this thing. For zone convention, we use open addressing. For hash function, the hash function, we use the GB2 quick start, and here's a bunch of reference, and you can find the source code of this thing in here. Oh shit. Twitter. Let's do a shit post, I suppose. Oh, thank you so much for 100 bits thing. You're welcome. You're absolutely welcome. I had a lot of fun today. It was really educational and recreational. So let's put this thing in here. All right, so we're gonna put in here. When I see unsafe keyword in someone's Rust code, should I put in someone's or not? When I see unsafe keyword in, I'm not sure what to put in here. When I see unsafe keyword in Rust code, yeah, I think that's fine. Is Rust referring to Rust or Rust lang? Yeah, let's put lang. So which hash code? Which hash code is actually more popular? So what people discuss on different, yeah. Okay, whatever. I think I'm gonna. I just have to make the shit post. Not really good at shit posting, so whatever. So you can find the source code of the hash table that we implemented in here. Yeah, I had fun. So I hope you did too. So. Oh shit! The project command doesn't even contain the link. I'm sorry, because I forgot to update it because I uploaded this thing only now. Anyway, that's it for today, boys and girls. That's it for today. Thanks everyone who's watching me now. Really appreciate it. Have a good one. See you all tomorrow. Tomorrow we're gonna work on email jam during the day stream. So yeah. That's it. I have nothing to say. I'm so tired. Thanks everyone for watching. Love you.